Hi, my name is Miss Schultz. This is grade 5 from Stout Field. Today we're going to do the respiratory lesson, and here is Mr. Crosslin.
Hey, thanks for that introduction. So we're going to talk about the respiratory system today. It's one of your body systems. And the respiratory system, it's responsible for you to do what? Breathe. To breathe, yeah. And when you take a breath, everybody take a breath. What just happened just then? What went in you?
Oxygen.
Oxygen. And it was in the air. And what went out?
Carbon dioxide.
Carbon dioxide. So the respiratory system is all about breathing. But before we go to the respiratory system, remember we talked about your heart, right? That's divided down the middle, and it's got two parts, a part here and a part here. And we call this like the right atrium, right? And this is the right ventricle. V's down, atrium's up. And this is the left atrium, right ventricle. And so you got blood, and I might use a blue. We like to use blue. Even though your blood is not blue, it might look blue.
That was the left ventricle.
Did I get the right? Oh, thank you for correcting me. That would be a strange person with two right ventricles.
Actually.
And so your blood looks blue, but it really isn't blue. It just looks that way through your skin. But we're going to use blue from your body. All these little capillaries all come together. All the capillaries, which are real tiny, they come back through veins, and they come in here to your right atrium, right? Yeah. So then this blue, we're going to use a blue because that means it has C, what's that called? CO2, which stands for carbon dioxide. It's the gas we want to get rid of, right? This goes down in here, pump, and then there's an opening where it comes back up and out of the top of the heart. I'm still making it blue. Where does it go then?
It goes to the left atrium.
Not yet. If it went over here, it would still be blue.
It goes into the lungs.
It goes to the lungs. I'm going to split the lungs. I'm going to put one lung over here and one lung over here. And why did I make this blue still? What is still in it? Carbon dioxide. But that, everybody do this. So what's kind of cool about this, in your lungs, the gases get exchanged or changed. The gases get changed. And now they have to come back to your heart. Where do they go?
Through the left atrium.
Left atrium. So it comes in here, and now it gets pumped down to here. And then where does it go?
To the body.
Out of the top to the body. Some of it goes to the head up here and arms. And then the rest of it goes down here to the body. And it goes all the way in. And it starts over. It goes all to the capillaries and starts over. So this is so cool about nature. Nature likes to go from high pressure to a low pressure. It pumps one way. Pump, pump. Now, every time you walk and move and squeeze, you're squeezing blood back this way. Your body squeezes blood this way. Your heart squeezes blood this way. So every time you move, you squeeze the blood back to your heart. And every time your heart beats, it pumps it out. Today, we're going to be talking about the respiratory system and what it does. And it's kind of cool. In fact, I brought a real specimen in. This is an organ, the parts of an organ of a pig lung, a pig's respiratory system. This is a little bit bigger than my lungs because a pig is a little bit bigger than I am. Now this has been preserved, which means it's freeze-dried. So your real lung is pretty wet and moist. And this one, you don't have to touch it if you don't want to, but here's the air tube, the trachea, where the air goes down, and it splits into the two bronchial sides, and it goes into the two big lobes. Now what's missing from this is all of these blood vessels coming and leaving and going back and forth to the heart. So this is kind of cool. I'm going to pass this around if you'd like to touch it. Resist the urge to squeeze it because, you know, you feel like you just want to squeeze it. but it will kind of ruin it. But that is a lung. Okay, I brought a special book in. This was kind of a famous book. It's called Gray's Anatomy. It's drawings of every muscle, nerve, cell, bone system in your body. And it's pretty amazing that people have spent many, many years studying the human body and learning what they're all the parts, the 206 bones that you have in your body, the hundreds and hundreds of different muscles. And it's a really pretty cool book. But you can take a look at this because it has some systems of the heart and some dissections of the heart. Anybody want to be a doctor or a nurse when you grow up? Well, you can see what some of the neat things that are to learn about the human body. Well, I tell you, this book has so much information, and I love some of these drawings. I'll tell you, there's something kind of cool about the lungs that you may not know. How does the air get in your lungs? I know you do it like this, and the good thing is, like, our muscles are they are involuntary. Your heart beats. You don't have to go, come on, heart, start beating. And you don't have to go, come on, lungs, take a breath. In fact, you can go to sleep and your heart still beats. And you still take a breath. That's a good thing. Can you imagine, like, trying to fall asleep? Wake up, start breathing, fall asleep. That's not a good thing. So luckily, our bodies, our heart beats, and our lungs continue to work even while we're asleep. But how does the air get in our lungs? How?
When you exhale and inhale.
I know, but what causes it to go in? What? Well, it goes through the mouth, the nose, down the trachea, into the bronchial passages, into the small little air sacs in your lungs. But what makes it go in? Do you guys have a pump out here going shh, shh, shh? No. I'll tell you what makes it. Here's the thing about science. Here's a thing about science. Science likes to go from, things in science go from a high pressure to a low pressure. Now that might seem simple to you. High pressure to a low pressure. Think about that for a second. Mr. Crosslin says most things in science like to go if they're a high pressure to a low pressure. What happens if you pop popcorn in a small bag? It gets hotter, it starts to pop. What happens to the bag? It will expand. So it goes high, it pops open. Let me put it this way. Anybody have any 2-year-olds at their house or little babies, brother? No. What if we put 5 4-year-olds in the closet? What are they going to do?
Screaming.
Bang around, bang, 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 bang. What's going to happen? What's going to happen when you open the door?
They're going to
They're going to come flying out. They're going to go from a high pressure to a low pressure. You know what I'm saying? So if you pump up a balloon, here's a balloon. You pump up this balloon, and it is filled with air. It's push, 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 and it's got so much air that it's pushing out. Got that right? Yes, yes? Out here in the sky, it's normal pressure. What's going to happen if you open up a hole in this balloon? It's going to go from a high pressure, the air is going to push out to equalize to a low pressure. Okay? Now you think, what does this have to do with the lungs? I'm going to tell you. This is so cool. So your lungs, first of all, you have a chest, and your chest is closed. It's closed. Inside of your chest, we'll come up here. Yeah, let's make this your head with your nose. I'm not very good at people. Okay, but anyway, that's your mouth. There's your nose. This is a very strange person. I know. Yeah. Okay. I'm more interested not in the brain. Okay, what I'm interested in is this. Inside of this, there is an opening here in your mouth and your nose, and that goes down, splits in your trachea to your two bronchial, and then here is your lung. It's a little sac, or a big sac, right? Now remember I said this is closed? This is closed, but it's open here, so air can go in and out. But how do these get bigger and smaller? You have one muscle. This is the cool part. Here's your muscle right here. Anybody know the name of your muscle that helps you breathe? Yes, the diaphragm. It's a big flat muscle down here. Now a muscle, you're going to learn next week and this week, a muscle can only do one thing. A muscle can only contract. Get smaller. If I want my arm to go that way, I have to use more muscles to make my arm go that way. Try it. Put your hand right here on these muscles, right here, on your bicep. Pull, feel how your muscle got smaller? Now put your hand down here on your triceps, back here, and straighten it out. Feel how they got smaller? You have opposing sets or opposite sets of muscles, but your diaphragm can only do one thing. Your diaphragm pulls down. This is so cool. Watch this. When your diaphragm pulls down, guess what happens to this big blue chest? It gets bigger. When the chest gets bigger, this has less pressure because we just made it bigger. So, if that's less pressure, the air out here goes, hey, we can help you. Air goes in, ding, 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 and these get bigger. Everybody do this. Your diaphragm just pulled down, your chest got bigger, air came in. Now the neat thing about it is this. On the outside of your chest, you have a bunch of ribs. These ribs are kind of hard. They'll stretch out, but you know what they like to do? Come back in. Stretch out, come back in. Here, try it like this. Put your hands like this on your ribs. Take a deep breath. Feel how they got bigger? Now relax. Feel how they came in?
Yeah.
All right, I'm going to show you an apparatus. Check this out. So here is a model of the lungs. This is your chest. What are the purple things?
Your lungs.
And here's your mouth and trachea. And so what will make this rubber thing down here?
Your diaphragm.
Diaphragm. Diaphragm, chest, lungs. My diaphragm can only pull one way. Watch when it pulls, what it's going to do. It pulls down, the lungs inflate. You relax.
Oh, I get what you
Listen, listen. And so this is how you breathe, by your diaphragm pulling down, your lungs inflating, and then relaxing. Pretty cool, I think. Now, here's the bad thing. What happens if you get something stuck in your throat? Watch what happens if I cover that up. Can't breathe. It would be terrible if you had a hole right here, because if you had a hole in your chest, you take a breath, air's going to go in there. So if you had a hole right here, luckily no one has a hole right here. When you took a breath, air would just go in, you would be in big trouble. So don't get a hole in your chest, okay? So when you take a breath, it makes bigger, less pressure, the air comes in.
Sounds like breathing.
So we've talked about why you need to breathe. That takes oxygen in, carbon dioxide out. And we know that your heart and your circulatory system delivers that to your body, right? We know how you breathe. It has to do between high pressure and low pressure, how your diaphragm is a muscle that pulls. But now let's see if it's really true that when we breathe out, everybody breathe out, if that is carbon dioxide, if that is CO2. You see, we can mix CO2 with water. If we can mix it with water, we can make something called carbonic acid. We can make an acid. Now, don't get too frightened. It's not going to be a dangerous acid.
It won't melt your hand.
It won't melt your hand. It'll just make all your skin fall off in a day. No, you're all right. Now, it's the acid. For example, Coca-Cola has acid in it. A lemon has acid. Orange, milk has acid, but it depends on how strong the acid is. Okay? Stomach acids are pretty strong. Acids go from a 0 all the way up to like a 7. 7's neutral, but if you're a 6 or a 5 or a 4, those are really dangerous acids when you get down here to 4. We're going to be looking at something that's probably 6.2 acid. But there's a way we can find out. we're going to see if we can make a chemical change. And there's three ways to see if a chemical change has occurred. One, you put two chemicals together and they bubble and fizz up, make a gas. Like, Alka-Seltzer in water makes a gas. Two, you put two chemicals together and they get hot. Or three, we put two chemicals together and they change color. And that's what we're going to do today. We're going to put two chemicals together and see if they change color. The chemical we're going to use is something called bromethanol blue. Bromethanol blue is a chemical that if you put carbon dioxide in it, it turns green. So we're going to prove that if we blow through bromethanol blue, if we have carbon dioxide, it should turn what?
Green.
Are you ready for that experiment? You want to try it?
Yes.
Okay, let's get started. So we have some trays we're going to pass out in just a second, and there's some chemicals in now. A couple safety rules. Number one, this is a chemical, so you don't want to suck up the chemical, all right? You want to blow air through it. Number two, you don't want to blow so hard that you make a mess. Now, I've done this with a bunch of kids, and everybody's been really responsible and not made a mess. Number three, the flat container is the control. The control means we're going to leave this one alone. We're going to compare. Are these the same color right now?
Yeah.
Yes. Blue, blue, same color? So here's how we're going to do this. Number one, don't suck up the chemical in your mouth. Number two, don't blow so hard it makes a mess. Okay, so number three, you have a control. It's important to remember what side of the straw you use, okay? All right, so if I have carbon dioxide in my breath, if it mixes with bromethanol blue, this should change from blue to green. Let's see what happens. Ready? Here we go.
That's creepy. Oh, that is cool.
Anything happen yet?
Yeah.
So I'm making a weak acid, carbonic acid, and oh, it is turning color. Let's see. Ready? That's one breath. Remember, don't suck air up. So check it out. Did we have a color change?
Yes.
So this means that bromethanol blue is an indicator of acid and it turned from blue to green. Now, what's going to happen if we just leave this overnight? What do you think is going to happen?
Turn blue.
Why would it turn back to blue?
Because it doesn't have any carbon dioxide.
The carbon dioxide will come back out of it, won't it?
Yeah.
But I can accelerate that. Watch this. I'm going to mix this with air. Let's see what happens. Ready? As I do this, it's getting mixed up.
It's starting to get darker.
It's starting to get darker green. I'm giving a chance for all the carbon dioxide to come out of solution.
It's turning blue.
Is it?
Yeah. Oh, that's
I probably should have left some of this green so we could compare. I left that, you know what I'm saying?
It's blue.
Is it back to blue yet?
Yeah. Not the same. Not the same, but it's blue.
Well, it must have a little bit of carbon dioxide still in it. Let's try it compared to the close. Okay, are you guys ready to try this?
Yes.
Okay, we'll pass out the materials. Remember the safety rules. No swallowing and no big bubbles.
It's like a little party. You're not sucking it up, right? can't stop. I'm gonna take your phone.
It looks like everybody had success blowing carbon dioxide through the solution and turning it from blue to green. Now, how can we get it back to blue?
Make it go through the air.
Make
If
it
we
lose the carbon dioxide.
Make it lose the carbon dioxide. So I gave you an extra cup, an empty cup, and so let's pour them from cup to cup and see if we can get the carbon dioxide out of solutions.
It's the blue that I had the first time.
Right, we'll save it in here. But yeah, we'll clean all of it off the end. Don't worry about it, okay?
And once you get it blue again, you can see if you can turn it back to green again.
I almost turned it back to the real blue.
Yeah,
Okay.
then get it back to green.
Yeah, Mr. Crosslin said that after you get it back to blue, you can try to get it back to green. You have to get it back to blue.
I wanted to try one more thing. So you saw that when I blew through the solution, the carbon dioxide in my breath turned that from blue to green. But what if I don't blow? What if I just use a pump? A pump. Is the pump working?
Yes.
Okay, what if I just use a pump to pump air from the atmosphere? What do you think? Is it going to turn green or blue? What do you think it's going to do?
I think it's going to turn green.
You think it's going to turn green? Is there carbon dioxide in the air?
No.
Well, let's find out. So hold that. Can you hold it by the top so they can see? Move your fingers. Hold it. Maybe there you go. Here we go. Ready? So now it's just getting air from the atmosphere. You see any change in the color? So that means there must not be what in this air?
No, it's getting darker.
You know what? It's not changing. Does anybody have any green? Let me see your green. Let's see if we pump air through your green. What do you think is going to happen if we pump air through the green?
It's going to turn blue.
It's going to turn blue. Let's see. Ready? Or bluer. Dark blue.
Back to its original color.
Wow. So that proves to me that the air around here is mostly oxygen. And the air coming from here is mostly what?
Carbon dioxide.
Color changed to green. Back to blue. Hey, this has been a lot of fun. We've learned the job of the lungs to bring oxygen to your body and exchange the carbon dioxide. We've learned how you breathe, and we've proved, well, I think so. Do you believe now that you have carbon dioxide in your breath? Yeah. Okay. Hey, thanks for a great lesson. We'll see you next time.